We're ready to start chapter 11, the last chapter of the semester, all about systems of equations. We're only going to do 3 sections. The first one is section 11.1, about systems of linear equations, substitution, and elimination. So some of this section should be review with systems of equations that are 2 by 2. That means 2 equations in 2 variables. If it's not a review for you or you're not remembering, please make sure to look at the book examples and the videos for the 2 by 2 systems. I'm going to, however, solve a 3 by 3 system for you using 2 different methods. We're going to use substitution and elimination. So let's go ahead and solve the system. X minus 2y minus z equals 1, minus x plus 3y plus 3z equals 4, 2x minus 3y plus z equals 10, right? Now this is 3 equations in 3 variables, right? And what are we looking to do? We're looking to find out that x equals something, y equals something, and z equals something. We're looking to find those 3 values. Okay? Alright, so 2 ways that we can do this. Yeah? There are 2 ways to solve. The first way we call substitution. Okay, now in order to make this a little bit easier, I'm going to number each one of my equations. X minus 2y minus z equals 1 is going to be equation 1. Number 2, minus x plus 3y plus 3z is going to equal 4, is going to be minus x plus 3y plus 3z equals 4 is going to be equation 2. And then 2x, not plus, 2x minus 3y plus z is going to be 10. Okay, so how do we do this by substitution? Well, we're going to take one of the equations, and I'm going to start with equation 1, right, and solve it for x. Why do I choose equation 1? Well, because I see that x doesn't have a coefficient here. It looks like it would be really super easy to solve. So if I take equation number 1 and solve it for x, I'm going to get x is equal to 1 plus 2y plus z, right? Now what I'm going to do is substitute this rearranged equation 1 into equation 2 to solve for x and y. Or I'm sorry, to solve for y. Pardon me. I could solve it for z, but I'm going to do y. You can choose either one. So I'm going to take this value and plug it in here in equation number 2 here for x. So let's go ahead and write out minus x. So this was equation 1. Equation 2 is minus x plus 3y plus 3z equals 4. But I'm going to plug the value of x from equation 1, which is 1 plus 2y plus z, into here, plus 3y plus 3z equals 4. And so notice what I have now. I now have an equation that's in only 2 variables, right? So the idea is I kind of want to get it down to where I can find one variable value. And then we'll plug it back in and find the others. So let's go through the motions of simplifying this. So if I distribute the negative, we're going to have negative 1 minus 2y minus z plus 3y plus 3z equals 4. Collecting all the like terms, we get y plus 2z equals 5. And solving for y, we get y equals 5 minus 2z. Alright. Okay, so now let's back up. We have equation number 1 up here, right? X equals 1 plus 2y plus z. We have equation number 2 is y equals 5 minus 2z. Now I'm going to take equation number 1 right here and number 2, and I'm going to plug them into equation 3, okay, where I can for x and y. Okay, so equation 3, right, 2x minus 3y plus z equals 10. Okay, now I have a value for x, right, which is 1 plus 2y plus z. So 2 times 1 plus 2y plus z minus 3, and I also have a value for y now, that's 5 minus 2z from equation 2, plus z equals 10. And looking at this equation, I have an equation in y and z, But if I take the value of y from equation 2 and plug it in yet again into this y, that's going to help a lot, because then I'll have an equation just in z, which I could solve really easily. So we're going to take 2 times 1 plus 2. Now we're going to plug in equation number 2 right here. 5 minus 2z, because it's the value of y, plus z, minus 3 times 5 minus 2z, plus z is equal to 10. Okay, now distributing and all of that stuff, I can let you do that. It's just a linear equation. But solving, you're going to get x equals 2, y equals, oh, I'm sorry. Let me do it for you. Pardon me. I just realized there's something I want to show you. 1 plus distributing 10 minus 4z plus z minus 15 plus 6z plus z equals 10. And then we distribute this 2. We have 2 plus 20 minus 8z plus 2z minus 15 plus 6z plus z equals 10. I'm going to collect all my z's. Let's see, I have negative 8 plus 2, that's negative 6 plus 6 is 0. Z! I love it! And then 2 plus 20 is 22, minus 15 is 7. So it will be z plus 7 equals 10, but if I subtract the 7 from both sides, I get 3. Okay, now I know z is equal to 3. That's one of my solutions. Now what I'm going to do is something that's called back substitute. I got that from equation 3. I'm going to go back now to equation 2, right? That tells me the value of y in terms of z. Well, now I know what z is. So y is going to be 5 plus 2 times 3. 2 times 3 is 6 plus 5 is 11. That's not right. I think I wrote it with the wrong sign. I did. It's 5 minus 2z. Pardon me about that. So it's 5 minus 6, which is a negative 1. Now I know what y is, what z is. I can go back to equation number 1 all the way up here and find x. So x is 1 plus 2y plus z. X equals 1 plus 2y plus z. So now I know that y is negative 1, and I know that z is 3. I get 1 minus 2 plus 3, so 1 minus 2 is a negative 1 plus 3 is 2. So notice I got my values, x, y, and z, that solve this system. Of course you can check them by plugging them in, and I would encourage you to do that. There is, however, another way to do this. Sometimes this is easier, okay, and sometimes it might be a little bit more challenging, but we want to talk about it because it's going to lead us to the next section talking about matrices and using matrices to solve systems. And the way we're going to do it is called it's called elimination, or sometimes people call it Gaussian elimination. Okay, I'm going to start it on this video, but I think we're going to have to go to another video to finish it. Okay, so this is the second way. Right, remember how it, whoops, my goodness. Ah, come on back, Mr. Thing. There we go. Whew. Remember how I said there were 2 methods for solving this? Okay, so 2, we're going to call it elimination. All right. Now, let's start with our same system. X minus 2y minus z equals 1. Wait, is this the same system we're doing? No, this is not the same system. Let's do a different one. Yeah, this is the same. This is the same one. Okay, sorry. Hold on. Pause, please. Sorry, I'm back. I know, my notes confused me for a second. Okay, number 2 will be minus x. We are going to use the same system, plus 3y plus 3z equals 4, especially since we already know the solution we're headed toward. And third equation, 2x minus 3y plus z equals 10. Okay, this is the same system that we were using before, okay? But before we start looking at elimination, I'm going to do something to it for a second. Let's say that we had this system, okay, but it didn't look exact. Let's say we had a different system, really, that did not have the minus x here, the 2x, and the negative 3y here. Yeah? Let's say that we just had this system. It would be really, really easy now to find the values of z, y, and x, wouldn't it? I know that z is 10. Remember, this is a different system, so it's not, because I erased some things. So z is 10. Then I could take the 10 and plug it in for the 3z, for the z here, find the y, and then once I had z and y, I could plug them in for the y and the z in equation 1, right? Okay, so wouldn't it be nice if we can make our system look like this, or create that? Okay? Alright, well, now what I'm going to do is put back the values. We had minus x plus 3y and 2x minus 3y plus z. Okay, so that's our original system. Alright, so in order to make it look like what I had before I put everything back, right, we would need to keep all the variables in one equation, right? Let me erase them again. Let's erase them again. Right? So I'm talking about the first equation here, right? It has all the variables, yeah? Then, notice in the second equation, all the variables but one are there. So we're going to eliminate one variable from another equation. And it happens to also be the second equation here, but it doesn't have to, we don't have to keep the variables in the first, get rid of them in the one in the second. It can be any of them. Okay? So notice here we have the x was eliminated, and we want to eliminate two variables, including one already eliminated from the last equation, whatever equation you have left, right? So if we could get our system to look like that, manipulate our equations somehow to look like that, it would be so easy to solve. Okay? Well, how do we accomplish this goal on our original system? Now I'm going to put the original system back. Minus x plus 3y and 2x minus 3y plus z. How do we accomplish this? Yeah? Well, we're going to use three principles. Yeah? And these principles come to us from the properties of equality. We are going to multiply one or any equation by a non-zero constant on both sides, right? We all know that's a legal move, right? You can multiply an equation by a non-zero number on both sides and it stays equal. We are going to interchange the positions of the equations, right? I could make the first equation the last one, the second one the first one, whatever I wanted to do. That's clearly not going to change the system. And number 3 is we can add a non-zero multiple of one equation to another equation. And you have seen this before, for sure. Okay? So to think about this, I want you to recall something that you learned in an earlier algebra class, right? If I had the system 3x plus 2y equals 6 and x minus 4y equals negative 1, and I want to solve by elimination, I can multiply the bottom equation by a negative 3. So I get 3x plus 2y equals 6 minus 3x plus 12y equals 5, and then add them together to eliminate a variable. Alright, well what we're actually doing here is that, oh I'm sorry, this should be a 3 and that becomes a 9, and I don't know what I'm doing with my signs. I'm trying to rush. Negative 10? Yeah. negative